Hello everyone, welcome to another video in this tutorial series where we are looking at creating our restaurant backend using TypeScript along with Node.js and MongoDB. And this tutorial is a part of a larger Flutter full stack development series. So if it is your first time, you can go ahead and check that out in the playlist and see the previous videos so that you might follow along. We are currently looking at creating our restaurant repository from the last video where we have written a test for our find all method, and we have also implemented our find all method here, and we will continue to implement our methods while writing tests simultaneously. So I will now look at the find one method, and to do this I'll go ahead and copy this test, and I'll just simply rename the method here to find one. I'll have the before where we'll prepare the database, and after where we'll clean up the database. So I am just gonna say, all right, for the positive result or the happy path, I am expecting that it should return a found restaurant. So I'm gonna call the find one method here, and this will accept a restaurant ID. So in this case it will be, I am going to use an ID from those records that are written to the database. So I'll create a variable here, and I'll call it inserted ID. Now, whenever the database is prepared, a series of documents are returned to show that these documents were inserted into the database. So I'm going to say docs equal await the result that is returned here, and as you can see, we get back a list of restaurant docs. So I'm just gonna say get the docs, and here I am simply gonna say inserted ID docs, and from the docs I can get the first document, and then I can get the ID from that. And since my doc is not a global variable, instead what I'm going to do is to set the ID docs and I'm going to get the ID, and then inside my find one I'll pass in the inserted ID, and this should check that this restaurant document actually exists in our Mongo database. So now I am going to say that the result ID should not be empty, or in this case I am expecting that the ID for the result should equal to the inserted ID. So that is my test, my positive path. Now for my negative path, I am going to say that if the restaurant is not found, then it should return a promise reject with error message. And now we'll say await find one, and I'm just gonna pass it a variable no ID, since I know that they shouldn't exist. And since it's returning a promise, I am going to catch that promise here in the catch block, and then inside the catch block, that's where I'll have my assertion or my expectation. So in this case, I expect that there should be an arrow. So arrow to not be empty. So that's my expectation. This method should be an async method. So now we have our happy, and we have our sad case or negative path, and we have our positive case. So now in our find one restaurant method, we will again go ahead, we'll copy this here so that we can set up our model. Then I am going to say that the result is equal to await the model find by ID, and I'm just gonna pass in the ID. Then I'm going to say if the result is null, then return that promise reject, and pass in the message here, restaurant not found. Otherwise, if the restaurant is found, then I am just gonna create a new restaurant object based on the data that is returned. So in this case, it will be result ID. We'll have name, we'll have type, so they will return our restaurant. Having an error here is missing the following properties. Promise. So our method here should be public async. So they will return our restaurant object from the data that we get back from our Mongo database. So now if I should go ahead and run this test, find one with no ID, it should prepare the database, fetch the first ID, and then check for no ID. In this case, there's no document with that ID, so it passed. And for this one, I'm expecting that the result should also be the same as the inserted ID. So there we have both of our tests passing. So now we have our find one method working as it should. we'll now go ahead and implement our find by location. So for this, again, I'll go ahead, copy all this, paste, change the name, find by location, do not need ID, therefore I do not need to return this document. I'm going to work with the same positive and negative path. So in this case, I'm going to use find by location. I'm going to create a location object with the, just going to give it a longitude and a latitude. Then I'll pass in my location here, but the find by location accepts also the page number and the page size. So the page number is going to be page 1 and a size 2. If we check our location search here, this is actually using the built-in location instead of our location class. So I need to import restaurant. So I need to import both restaurant and location. Here we have it. But now it seems to not be conforming to our interface. So we'll find our interface, my restaurant repository, find by location. This is using the built-in. So again, we'll import location. Right. So now back to our find by location method. Everything seems great. Inside of our positive case, I am going to use a location that is what I have in the helper. So in the helper, I have a location of 4033 and 7323. So I'm just gonna say 4033, 73 here, 4033 and 7323. Then find by location, page 1 and a page size of 2. And now I am expecting that the result, I'm gonna escape to overall results. data, since it's returning a pageable length, and I'm gonna say the length should be 2, since I have multiple restaurants in that location. So now inside of my find by location, I'll go ahead and implement this method again. I'll copy and paste this, and as you can see that I'm copying and pasting this a lot, so you can actually create a method that sets up the model here and then reference that method instead of copying and pasting the same code all the time. So now I have my model. I need also my page options, since this is a pageable method. So in this case, my page options would be the page that I passed in, and the limit would be the page size. And since we are using the library will paginate, in order for that library to work with GeoQueries or GeoNear, we have to use one of those flags in that library and set it to true. So there's a flag called force count fn that needs to be set to true in order for us to execute GeoNear queries using our paginate library or package. So now I am going to set up my GeoQuery that will determine if a restaurant is within a certain location based on a certain distance. So the location here, the GeoQuery is written like this, where you specify the field that we are searching, or the geospatial field that we set up in our last video, which is a part of our restaurant schema that has a index of 2D sphere. So we have an index on this particular location field, and so we are telling MongoDB that this should be a geospatial query using this location field, and we want to say near. So we're gonna check those restaurants near, and then we're gonna pass in the geometry, or the near. The geometry represents the starting point, or the coordinates that we are asking Mongo to check if there are any restaurants near this particular coordinate. So for geometry, we need a type, and the type must be a point. And then we need the coordinates, and these coordinates represents the point from which we are checking if there are any restaurants located near this point. So in this case, it will be location, and it is always the longitude first, followed by the latitude. And then we need to give it a distance. So now we can give it a max distance, and we can give it also a minimum distance, but I'm only giving it a max distance, and the distance are in meters. So now this is 2 meters. So I'm telling it to check to find all restaurants that are near this location within 2 meters. I'm hard coding 2 now, but it will be good that we add 2 as, or the distance, as a parameter in the method itself, so that the client can pass in how near or what distance they want to check using this query. So then I'm going to say now that my page results model, then I'm going to use the paginate option and pass in the geoquery that I have and the page options. Then I'm gonna catch whatever error, if there's any, and simply return null. So now that we have our page results, I'm just gonna say return and call our private method restaurant from page results and pass that page result. Also, we need to make this method public async, and there we have our find by location. And now we can go ahead and run our tests. And as you can see, we're having an issue here, so we cannot execute our test as we would. And as I look, I see there's a red indicator here suggesting that there's an error somewhere here. If I look inside the console, then there is some module error. I think it has to do with restaurants. I'm just going to remove that and then re-import it. So that should fix things. If not, we can go to our test explorer here. There's an arrow, we can refresh that and see what happens. So now everything seems good. We can go ahead and run our test. So the first test we are running, this location shouldn't exist, so we're expecting an error. We have our test pass in there. The second test, this location exists, therefore we should get back some restaurants. And there we have both of our tests passing, so we are going quite well. Now we need to deal with our search, and the search is pretty similar to the other two since it's returning a paginated result. So what I have done is to gone ahead and written two tests for my search. I have not implemented the method yet, but I have written those tests, and it's pretty similar to what we have done before, which to return an error if we do not find any result based on the search query, and to return those restaurants that matches the search query. In this case, restaurant name, which is what we have named those restaurants inside of our helper method of those restaurants that we have written to the database. So now if we go ahead and implement our search, which is to copy and paste the model, and by now you should have created a method that you can reuse with this piece of code in it. So now I have my model. Again, I'm gonna set up the page options. So I'm just gonna copy and paste this page option since it's a pageable result. This time I'm not using geoquery, so I can remove the force count. Then I can say that to use MongoDB text search feature, which uses indexing to create index search on text queries, I am going to say, well, this text query should be text, which is the index, and that the search value should be the query value or the thing that I am searching for. And then I will say page results equals await model paginate, and I'll pass in my text query and my page options. Then I'll catch the error if there's any and simply return null. So this code is quite familiar to you guys now since I've been reusing it a lot. And I'll simply, again, since it's similar to the others, return and pass the page results there. And there we have it. So if I go ahead and run this test, I am expecting this to fail since there is no restaurant with this name. So now we have a passing test, which is true since there's no restaurant with this name, so we are expecting error. And for this one, we are saying that we are searching for restaurants with this name, therefore we're expecting 2 restaurants, which is equal to the size of the page that we are querying. And there we have it. All of our tests are passing as they should, and that is quite lovely. So we have implemented most of the methods so far inside of our restaurant repository, and we have only our menu method to implement, which involves a few more steps, which we'll have to set up those models and also add those data to the database so that we can query that. So we'll go ahead and quickly do that. So inside of our, again, models, we'll create another file and we'll call it menu model. Then we will go ahead and set up those documents and schemas and models as we have done the same for the restaurant. So I'll say export interface. Again, this extends our Mongoose document. We'll import our Mongoose document here. So from And inside of our menu document, we're going to have name. We're going to have the restaurant ID for that menu. We're going to have an image URL and a description. So we have that menu, our menu document. Then we need also our menu item document. So we'll have menus, and then we have those items that are associated with those or that particular menu. Then we'll say that the menu items will be a name. They will have a menu ID to know which menu they are associated or belong to. We'll have a description. I'll have image URLs, which is a string array in case we have some images associated with this particular menu item. And then we have the price, which is a number. And you probably could have other fields on it if you so desire, like tax rate or tax amount or that kind of thing. So again, just like our restaurant model, I'm just gonna create a menu model which simply extends a mongoose model of the type document, which in this case it is the menu document. Same thing with our menu item. Just gonna copy and paste this, change the document to menu item document, change the name of the model to menu item model. Now we need to have our schemas, so gonna say our menu item schema, new mongoose schema. And again, we from our restaurant, we know what the schema represent and how that is set up. So I'm just going to go ahead and create the schema quickly. So I have created both my menu item schema and my menu schema, and it is the same thing as above. We have all the properties and the specific Mongo types and if they're required or not. And we have the same thing here. So we just now need to export both schemas menu item schema, and we are good to go as far as our menu model is concerned. Now, in order to get this up and running, we need to populate our Mongo database with menus belonging to each of these restaurants. So again, I'll go ahead and copy a list of JSON that I have already prepared. So here I have a list of menu. In this case, it's a single menu, which is a launch menu. Then we have some items. Now we need to get all these menus and items. So we need to get these items associated with this menu and this menu associated with each of these restaurants. And in order to do that, we will have to go ahead and create those models, both menu and menu item. So I have added both the menu model and the menu item model here, following the same principles as with the restaurant model. And as you can see, we have our menu schema with our menu item with our menu item schema. So we'll ensure that they are indexes, and here, instead of returning this here, I am going to store those restaurant docs, because I need to use the IDs from these restaurants to insert those menus. So I'm gonna say here menu docs equal await. I'm gonna create a method insert menus, and that method gonna accept the restaurant docs and the menu model to insert those menus. Go ahead here at the bottom and create that function. Sync function insert menu. So I have gone ahead and created this method which accepts the restaurant docs and the menu model, and it's a simple method. All it does is create an empty array list or empty array of restaurant menus, and then loop through each of the restaurant documents that were created and simply say that take those list of menus that we have here, this array list here, since we have a JSON object in it, but there's no ID associated with it. Take that list of JSON menus and add the restaurant ID to it. So I'm basically adding the same menu to each restaurant that was written to the database. So I push that to this menu array using the spread operator in JavaScript here, and then I'll simply say menu docs, use the menu model to insert all those restaurant menus into our Mongo database, and return the menu docs, which will use those menu docs to insert menu items following a similar principle. So again, I'm just going to go ahead and create the method to insert menu items. So here we have the method to insert menu items, pretty similar, except the menu docs, which is the list of menus that were created in MongoDB, the menu item model, which we'll use to insert the menu items into the database. We have an empty items array, and then for each menu that was inserted into the Mongo database, we are going to add an ID, or the ID for that particular menu, to our array of menus here, or JSON array, which doesn't have an ID. So we're going to add the ID so that we can link the menu to that menu item. And we use the spread operator here to break out each of these items that we might add the ID to it. So we are basically modifying this JSON object to insert an ID, and we are pushing each of those newly created JSON object with an ID to the items array. And then after we have added those objects, those menu items to the array, we simply use the model to insert all those menu items into our Mongo database. So we have both functions to insert menus and to insert menu items. So we'll just go ahead here and say, after we have inserted our menus, then we should now insert our menu items. So we'll say await insert menu items, and we'll pass in the menu docs and the menu model. Then the last thing we'll do is return those restaurant docs, since we have tests that are dependent on us returning these restaurant docs. So there we have it, so that we can insert all the records into the database to set it up for restaurants and menus, so that we can run our tests there. And now for our cleanup, we need to remove more collections, since we have added new collections. So we'll do the same thing, connection db, drop collection, we need to drop menus, and we need to drop menu items. So drop menu items. So now we have everything ready to prepare our database. Inside of our spec, if we should go ahead and create those spec for our menus. So for our menu spec, we have prepare the database, we have a restaurant here, we get the ID, and then we are going to get all the menus that belong to that restaurant. And so we're expecting that the length of the menu is 1, since from our helper we have only one menu. And then we are expecting that the items in that menu, that the length should be equal to 2, which is based on our helpers and what we have set up here. So we have one menu and 2 items. So that is what we are expecting in our test. So for our menu method, I am going to go ahead and to create both the menu schema, or model rather, and the menu item model. These I need to import. So now we have our menu model and also our menu item model. We're going to fetch the list of menus first. So I'm going to say menus, await menu model, find, and I'm going to pass in the where condition. In this case, where restaurant ID must be the restaurant ID passed in here. I'll make this method public async. Then I'm going to say that if the menus is equal to null, I'm simply going to return a promise reject that says no menus found. Otherwise, I'm gonna say get all those menu IDs, which is menus map to transform. Just gonna use the letter M for menu and say give me the ID. So I'm basically fetching all the IDs from the list of menus that were returned. Then I'm gonna say items, menu item model, find. Then I am going to find it where menu ID is in those lists of menu IDs. So I'm gonna find all those items that are in this list of ID. Then I'm just gonna create a method that says return menus with menu item. So this method rather simply gonna associate each item with each menu and return the menu, since our menus domain object has a list of menu items associated with it. So I'll just go here and create that method. So I have gone ahead and create this method, which is a simple method. So if we look at how this method works, we can see that it accepts an array of menu document and an array of menu items. And what happens is that we are returning a list of menus, and each menu have a list of or an array of menu items associated with it. So we use the map function again to transform the results here inside here of this array. So the map function iterates through each menu item, or menu in this case, not the item, and then we create a new menu object and we pass in the information from the current menu that we are processing. And then since each menu has a list of items, what we do is that we say that we're gonna set items to the items here, and we're going to filter out only those items that belong to this particular menu using the menu ID. So we are saying if the item menu ID is equal to the ID of the menu that we are currently processing, then we are going to map or create a menu item from that. And so that's where we create a new menu item and we pass in each piece of information that belongs to the menu item. And as you can see, we have an error here, and it says that we're expecting 5 arguments, but we got 6. And I think that has to do with our menu item, which is missing the name property. So we are missing the name property. So if we go here, everything should be okay. And please verify that the data that we are entering here, or we are adding in the construct of the menu item, that it is in the same order as we have it here, or else we might find that we enter the name inside the description if we should get it wrong. So if we should have description here instead of name, we might find that we have the wrong data in the wrong fields. But now we have our menu set up, we have our method, or get menus method. If we go ahead and run the test now, return restaurant menus, then we expect to have a passing test. And there we have our tests working. So we have created all the methods of our restaurant repository, and we are now ready to move into creating our controllers and routes so that we can quickly finish up this restaurant module on the back end. So again, thank you guys for watching. Like, share, subscribe if you haven't subscribed yet, and see you in the next video as we try and complete as quickly as possible this back end so we can move on to the next module and wrap up this application. So see you in the next one, and remember that the code is available on GitHub. Thank you for watching.